Have you ever wondered how global warming could possibly lead to another ice age? It's a question that might sound contradictory at first. After all, how could warming lead to freezing? But paradoxically, these two seemingly opposite phenomena might be more connected than you think. Let's start by understanding the concept of global warming. It's a term that refers to the ongoing increase in Earth's average temperature. This rise in temperature is primarily due to human activities, predominantly the burning of fossil fuels, which releases greenhouse gases into our atmosphere. These gases trap heat, causing the Earth to warm up. Now, one of the most visible effects of global warming is the melting of polar ice caps. This is causing sea levels to rise, and it's also flooding our oceans with fresh water. While these are serious concerns in their own right, the influx of fresh water into the ocean has another, less obvious consequence. It could potentially disrupt one of the most important ocean currents, the North Atlantic Current. The North Atlantic Current is part of a larger system of ocean currents known as the global conveyor belt. It's like the Earth's central heating system, transporting warm water from the tropics to the North Atlantic. This process helps moderate the climate of regions like Europe, making them warmer than they would otherwise be. However, the introduction of large quantities of fresh water from melting ice caps can disrupt this current. Fresh water is less dense than salt water, so it can float on the surface of the ocean, creating a barrier that prevents the warm, salty water from sinking and circulating back to the tropics. This could slow down or even stop the North Atlantic Current, leading to a drastic cooling in regions like Europe. So, while it may seem counterintuitive, global warming could indeed be the trigger for a new ice age. As our planet continues to warm, the paradox of global warming becomes more apparent, reminding us of the complex and interconnected nature of our planet's climate. Now, to understand this paradox, we need to delve into what an ice age actually is. Imagine the world in a deep freeze. The temperature of Earth's surface and atmosphere plunges for an extended period. This is not a brief winter chill, but a long-term reduction that lasts for millions of years. This, my friends, is an ice age. During an ice age, the planet's warmth retreats, and the ice takes center stage. The ice doesn't just visit for the winter, it sets up residence, expanding across continents and forming vast ice sheets and alpine glaciers. The polar ice caps, already a frigid wasteland, grow even more extensive, locking more of Earth's water in its frozen form. The world becomes a realm of ice and snow, a dramatic change from the temperate and tropical climates we're accustomed to. But here's the interesting part. Ice ages are not random, one-off events. They are part of a natural cycle that our planet has been following for millions of years. Just as the Earth rotates on its axis and orbits the Sun, it also cycles through periods of warmth and cold, known as glacial and interglacial periods, respectively. Currently, we are in an interglacial period, a time of relative warmth between the ice ages. That's why we have summers and winters instead of perpetual ice and snow. But don't let the current warmth fool you. It's merely a temporary reprieve in the grand scheme of things. The Earth has spent about 80% of its history in the icy grip of an ice age. Ice ages have shaped the course of life on Earth, influencing evolution, migration, and even the rise and fall of civilizations. They are a testament to the Earth's ability to change and adapt, a reminder of the planet's dynamic nature. So, while we might be enjoying a relatively warm period now, history tells us that this won't last forever. The ice will return, and with it a new ice age will dawn. Our planet has a natural heating system, often referred to as the global conveyor belt. But what happens when this system gets disrupted? The global conveyor belt is a massive oceanic current that circulates warm and cold water around our globe, acting like a giant thermostat. This current is driven by differences in temperature and salinity, the saltiness of the water. Warm, salty water from the tropics flows along the surface towards the poles. As it reaches the colder regions, this water cools down and becomes denser, sinking deep into the ocean. This cold, dense water then flows back towards the equator, where it warms up and starts the cycle again. This constant circulation of water helps to distribute heat around the world, keeping the tropics from getting too hot and the poles from getting too cold. It's an incredibly important part of our planet's climate system, ensuring that life as we know it can exist. But here's the twist. Global warming could disrupt this delicate balance. As the Earth's temperature rises, polar ice melts faster than ever before. This influx of fresh water into the oceans can lower the salinity of the surface water. Remember, it's the saltiness that allows the warm water to sink when it reaches the poles. But if the water isn't salty enough, it might not sink. This could slow down or even stop the global conveyor belt. And if the conveyor belt stops, the heat distribution it provides would cease. The tropics could become unbearably hot, while the poles could cool dramatically. This sudden shift in temperatures could potentially trigger a new ice age. It's a complex system with a multitude of factors at play, but one thing is clear: our actions have consequences. Global warming is more than just hotter summers and milder winters. It's a disruption of the natural balance of our world. It's a delicate balance, and global warming could tip the scales towards a chilling future. If an ice age were to happen, are we prepared to handle it? This question may seem far-fetched, but it's worth pondering. An ice age would bring with it a slew of challenges that could profoundly impact human civilization. The first and most obvious consequence would be the drastic drop in temperatures. This intense cold could render large portions of the planet uninhabitable, forcing populations to migrate to warmer areas. This mass migration could lead to overcrowding in temperate regions, putting a strain on resources and potentially leading to conflicts. Food production would become a significant challenge. With less arable land available due to the encroaching ice and snow, we would need to revolutionize our agricultural practices. Indoor farming, vertical gardening, and other innovative methods might become the norm, as we strive to feed a growing population under harsh conditions. Our energy needs would also increase dramatically as we fight to keep the cold at bay. This could lead to a surge in demand for fossil fuels, ironically contributing to the very global warming we've been trying to combat. Alternative energy sources such as solar and wind power could help offset this, but their efficiency would likely be compromised in a world blanketed by ice and snow. Infrastructure would have to be redesigned to withstand the severe weather conditions. Roads, buildings, and entire cities would need to be constructed to endure the freezing temperatures and heavy snowfall. This could require a massive investment of resources and a significant shift in architectural and engineering practices, and let's not forget the effects on our planet's biodiversity. Many species would struggle to adapt to the new conditions, potentially leading to mass extinction events. This could disrupt ecosystems and food chains with unpredictable consequences for humanity. In short, surviving an ice age would require a complete transformation of our way of life. It would require innovation, cooperation, and resilience on a global scale. It would test the limits of our adaptability and our ability to plan for the long term. Surviving an ice age would indeed be a monumental challenge for humanity. So, what have we learned today? We've delved into the paradox of global warming and the prospect of an ice age. At first, it seems counterintuitive. How could a warming planet possibly plunge into a deep freeze? But as we've discovered, the Earth's climate system is a complex and delicate balance of interconnected forces. We've touched upon the concept of an ice age, a period of long-term reduction in the temperature of the Earth's surface and atmosphere, resulting in the presence or expansion of continental and polar ice sheets and alpine glaciers. These periods of extreme cold can last millions of years and have profound effects on the planet's climate, geography, and life forms. We've learned about the global conveyor belt, a vast oceanic system that circulates warm and cold water around the world. This giant conveyor belt plays a crucial role in regulating the Earth's climate. However, it's also susceptible to disruption. If the flow of warm water slows down or stops, it could trigger a cascading series of events leading to a new ice age. And then, we've pondered on our preparedness, or rather unpreparedness, for such a drastic change. An ice age would have dire consequences for human civilization. Agriculture would be severely impacted, cities would need to be redesigned, and we'd have to adapt to a colder, harsher world. It's a sobering thought, but one that underscores the importance of understanding and respecting the forces that shape our planet. In conclusion, while our immediate concern is undoubtedly the ongoing threat of global warming, we must not lose sight of the long-term climate cycles that could plunge our world into an ice age. It's a fine balancing act, but one that's necessary to ensure our future on this planet. So, while we continue to battle global warming, let's also keep an eye on the chilling possibility of an ice age. After all, our survival could depend on it.